Somewhere under a major city right now, a machine the length of a football pitch is chewing through the ground at about the speed a garden snail moves, and behind it, it is building a finished tunnel as it goes. The city above never feels a thing. This is a tunnel boring machine, and it is not really a drill. It is a mobile underground factory. At the very front is the cutter head, a huge rotating steel wheel studded with cutting tools. It presses against the ground and turns slowly, and the whole machine pushes forward off the tunnel it has already built behind it. But the cutter head is only the first few meters. Stretching back behind it for 100 meters or more is the backup, a train of trailers carrying the hydraulics, the power, the control cabin, the conveyor, and the crews. The people driving it are not at the face. They are in a control room further back, watching the ground through sensors, because at the face itself the conditions are far too dangerous for anyone to stand. Before any of that, the machine has to get underground in the first place, and a TBM does not fit down a manhole. Crews dig a deep launch shaft at the start of the route, a vertical box sunk into the ground and braced against collapse, often 30 or 40 meters deep. The machine arrives in pieces on dozens of lorries and is lowered down the shaft with heavy cranes and reassembled at the bottom, sometimes taking months. The cutter head alone can weigh hundreds of tons. Then it is aimed at the tunnel wall and switched on, and from that moment it will not stop, running around the clock 7 days a week, because stopping a TBM in soft ground is risky. Leave the face unsupported and still for too long and the ground can seize the machine solid. So tunneling crews work continuous shifts for months, sometimes years, keeping it moving. Digging under a city is not the hard part. Stopping everything above from collapsing into the hole is. Soft, wet ground under a city wants to flow into any space you open up, and if it does, the surface above sinks and buildings crack. So a modern city TBM never leaves the face open. It balances it. In an earth pressure balance machine, the excavated soil itself is held in a sealed chamber right behind the cutter head, and the machine deliberately keeps that chamber packed full, so the pressure of the soil inside pushes back against the ground trying to squeeze in. The operator matches the amount of soil removed to the exact speed of advance, keeping that balance constant. In wetter, sandier ground, a slurry machine does the same job with pressurized bentonite, a clay suspension pumped to the face to hold it up, then piped back out carrying the spoil to be separated at the surface. Either way, the ground outside never gets the chance to move. Here is the part that surprises people. The TBM builds the permanent tunnel as it moves, not afterwards. Just behind the cutter head sits a shield, a steel cylinder that holds the freshly cut ground open like a temporary umbrella. Inside that shield, a robotic arm called the erector picks up curved precast concrete segments, delivered up through the backup, and bolts them into a complete ring against the tunnel wall. Ring after ring, the tunnel lining is assembled one segment at a time. The machine then pushes forward off that ring it just built, using hydraulic rams, and the whole cycle repeats. As the shield moves ahead, it leaves a small gap behind the concrete ring, and that gap is immediately pumped full of grout so nothing can settle. The tunnel you eventually ride a train through was quite literally bolted together underground by a machine reversing away from you. A city tunnel has to arrive at the far end within centimeters of where it was designed to be, often after kilometers underground with no view of the sky. So the machine is guided by a laser survey system that constantly measures its exact position and angle against a reference point, and steers by pushing harder on the rams on one side than the other. All that excavated ground, the spoil, is a logistics problem of its own. A single machine can produce thousands of tons of muck a day, and it all has to travel back down the length of the machine on a conveyor or in muck cars, up a shaft, and away in trucks or barges, usually at night to avoid clogging the city with traffic. People always ask how fast it goes, and the honest answer is slow. A good day might be 10 to 15 meters, and a hard day through rock or a tricky mixed face might be almost nothing. That is because speed is never the goal. Control is. Push the machine too fast and you take out more ground than you support, and the surface above starts to drop. Engineers monitor that constantly, with survey markers and sensors on the buildings directly over the route, watching for movement measured in millimeters. If a building starts to settle unevenly, crews can inject grout into the ground beneath it to lift it back, a technique called compensation grouting, sometimes done live while the machine passes underneath. The whole operation is a slow, continuous negotiation with the ground trading speed for the promise that nothing above ever cracks. None of this is cheap. A large tunnel boring machine is custom built for one specific job, its diameter and its ground conditions, and can cost tens of millions of dollars before it even turns. Tunneling under a dense city routinely runs into hundreds of millions or billions for a single line. Because you are not just boring, you are threading between existing metro tunnels, sewers, building foundations and utilities, sometimes with only a meter or two of clearance. And at the end, the machine often cannot be reversed out. On many projects, it is simply steered slightly offline into a purpose-dug chamber, stripped of its reusable parts, and the shell is left buried in the ground forever, entombed under the city it built. Follow for more construction facts hiding in plain sight.